Hello and good afternoon, everyone. This is our webinar number 2, where we are today going to discuss about OneM2M architecture and basic principles overview. And today, to conduct the webinar, we have our colleague Xavier from Etsy, and I will briefly give you a description about Xavier's background. So Xavier has almost 16 years of industry experience, 6 years with telecom R&D, working with companies like Orange, and almost 10 years with Etsy. So Xavier has deep technical background, and now he is also responsible for the India EU standardization project, where today in that capacity he is making this presentation. So before I hand over to Xavier, can you hear me? Can you confirm?
Yes, sorry. Hello, I can hear you. Welcome.
Yeah. Okay, so welcome Xavier, and before you start making the presentation, I also want to use the opportunity to tell our participants about our upcoming activities. So I just want to make 2 announcements today. One is that our webinar number 3, which is on 7th April, same time, 2:30 p.m. to 3:30 p.m. Indian Standard Time. And the title of the webinar would be Information-Centric Networking, the Future of Internet. The presenter would be Mr. Samar Shailendra from TCS Research and Innovation. So we look forward also, for you to join continuously or regularly on these webinars with us. And the another announcement I want to make, which is that through the project, we're also planning a one-day workshop here in New Delhi in association with CDOT. The title of the workshop is Future-Proof Smart Cities with a Common Service Layer, a standards-driven approach. So today's webinar, in fact, is very special in that sense because I can see that there are many colleagues from CDOT also participating in the webinar, and OneM2M is actually providing this common service layer and is a very important development in the field of smart cities. And in fact, Etsy has just released a white paper on relevance of OneM2M for smart cities. So over to you, Xavier, without further ado. Please continue your presentation.
Okay, so thank you, Sachin. I think you have already covered my last slides. This is a presentation about, it's a very high-level overview of OneM2M. It's more for people to be familiar with OneM2M, so I'm sure the people here attending from CDOT will already be quite familiar with those concepts. So we'll go briefly about on the following topic: what is OneM2M? What are the basic principles that govern the work in OneM2M? And what the architecture is. So moving to OneM2M. So OneM2M is a global partnership that was established some time ago between standard developing organizations and industry associations and fora, with the goal to work towards the unification of the global M2M community. And they wanted to do that by enabling the federation and interoperability of M2M systems across multiple networks and across multiple technologies. The main goal is to create consistency, as I write here, in how devices, servers, and applications communicate through a standardized M2M service layer with the with the intent to increase interoperability, to have cost effectiveness and therefore economies of scale to reduce the fragmentation in the market and consequently being able to address a larger market that is conformant to or compliant to the same set of specifications. The idea is to make sure that we are able to interwork with legacy, proprietary, and sector solutions, and the way to do that is to separate between the protocol interworking and the semantic interworking. And I'll come back to this aspect of semantic interworking. Next slide is about what I call breaking barriers and cross-domain interoperability. I think IoT is very specific in the way that even more than consumer domains, it's built in silos, and each and every I mean, it's very easy to see that a number of applications are built on specific system with vendor-specific applications and solutions, and ultimately this is some kind of a large-scale fragmentation that is taking place with a number of applications that are ultimately disconnected or connected at a very high cost because they are not interoperable in the first place. And the whole purpose of the OneM2M project is to be able to have some kind of convergence and commonality between these different deployments, so that they are actually not separate things ultimately, but they can be considered one system that takes advantage of a common service platform. And it's very important to understand that this common service platform enables interoperability both at the level of communication and how systems talk to each other, and then also about the vocabulary they use, or how can I say, the format of data, which is also interoperable and therefore easier to be shared and used across different applications. And ultimately, this allows for a proper interaction and seamless interaction between a number of applications and devices that are otherwise not homogeneous. I would like to continue with a brief overview of this OneM2M project. So I mentioned the standards developing organizations. They are here in the blue boxes. So going from where the sun rises to where it sets, we have ARIB and TTC from Japan, TTA from Korea, CCSA from China, TSDSI from India, ETSI in Europe, and TIA and ATIS in the US, that are all regional organizations that have decided to team up to make the project a global one with global reach. And all those organizations allow their own members to be participants in that project, which is the reason why we have over 200 member organizations in OneM2M through 8 partners. And on top of that, we have also, as you see below, 6 other partners that have joined the project, and which are a partner of type 2, as we call them, and that contribute directly and under their own name in the work. next slide is a quick show of all the well-known companies that are present in the work of OneM2M. It shows you that they are very diverse and come from various places in the world, and it's just a sample. And then about the OneM2M implementations, we have a number of industry-driven open source implementations. The mentions here are not exhaustive, but it shows that there is a good number of open source implementations, and that there is an interest by the community to have such open source implementations. And then below we are listing a number, and also here it's not exhaustive, also a number of commercial implementations and demonstrations that are seen and available in the field. And also I would like to mention here, and I will come back to this, that we've had so far 3 very successful interoperability events held in 2015 and 2016, with a very encouraging participation, and the next one will be held in May 2017. Next slide is about the OneM2M organization, and it's not here to tell you who is sharing what. It's rather here to explain to you that if you look at the okay, you have the red part, which is the steering committee, which is the higher decision power and as the name suggests, steering force for the OneM2M project. But then the heart of the technical work is the technical plenary and its working groups, where you will notice, if you look from left to right, that we have a requirements working group, which is there to collect use cases and requirements, and derive requirements from those use cases by representatives of all the industry, and which is here to capture basically the market needs. And then when the requirements are captured, the work, technical work or more technical work kicks in with first the architecture work, and then as you see, as almost parallel tracks, the work on the necessary protocols and necessary security mechanism starts together with the work on the semantics. And when those technical solutions are delivered, of course, to deliver a complete set of specification, then also OneM2M delivers the necessary specification to test the implementations and to make sure that conformance testing can take place, which comes basically in addition to the interoperability events that OneM2M organizes as separate events. Okay, and so next phase, which is not yet displayed here, is the work on certification, ultimately. A quick word about the timeline. So we can see that the project was launched end of 2012, and took some time to get on its track, to assemble all the use cases and requirements, and basically try to understand how to have the right approach to such a wide scope of applications and sectors, I would say, which basically was the work for the release 1 of the specifications, which were issued beginning of 2015. And from then on, as you can see, there is a kind of a momentum being picked up by the project with release 2 of the specification, which was issued second half of 2016, and in the meantime, 2 interoperability events to work on the basis of release 1, and the third interoperability event took place end of 2016. As I mentioned, the next one is in May, and I think it's very important to notice that a good rhythm of interoperability event is maintained, because that's ultimately where people get together and see in real conditions, I would say, in how their implementation fares together with others' implementations, and that's some kind of real-life test, which is very important. Okay, and release 3 of the work has now started, and it's basically in the works. And as I mentioned earlier, we see the first deployments or and large-scale commercialization taking place. So let's go to the basic principles, and what I described here as the role of the M2M service layer. So basically what items have been identified by the project when starting their work, where they wanted to go, what they wanted to reach, and it was all about defining the expectations and making sure that all the aspects of the issue were addressed. So the intent is to have that software/middleware layer, which is something that will sit between the applications on one hand and the transport or network layer on the other hand, and that layer, will be integrated into the devices, into the gateways, into the servers altogether, so that they all have the same set of functions they can rely upon, and so that they all have interfaces with each other that rely on the same API or same command set, I would say, and which means that sensor, actuators, things, routers, and cloud are all connected through that service layer. And the idea is ultimately to connect the devices that are producing data to the applications that will use this data or this resource in a reliable manner and in a secure manner, because of course we are not leaving aside the issue of integrity of data, confidentiality of data when required, and also so next point is that the service layer makes it completely transparent for the applications what kind of network layer is used below. The idea is to have the abstraction and to make sure that to some extent we are transport layer agnostic. The service layer also is there as a a system that can control when communication happen, basically when they need to happen, so that it's only taking place where necessary, and make sure that the resources are not used in a way that would be that wouldn't be energy efficient or also scalable, I would say. So as I just mentioned, this increases the efficiency of data transport. The service layer also provides all the means to store, retrieve, update, delete data between applications and sensors or whatever things are connected to that service layer. This is all done through a system that supports access control policies, so that we don't have unauthorized or unidentified resources that access the data unless we want them to be all able to read and access the data. The service layer also supports event notification, which is important to make sure that some devices are aware of the evolution or update of some values in the servers. It supports the ability to talk to not only one device but also a group of devices, and in more general manner, it allows the management of devices on a large scale. So the principle guiding the work were that the project wanted to have a distributed architecture so that ultimately the system is scalable. For the communication between devices, a request-response model has been chosen, which is a very efficient way to have some kind of maybe bursts of communication and then keep the system silent. This allows for a robust data transport when needed. It also allows for the possibility of using mechanisms for publish and subscribe. This also is a kind of a flexible structure in the way that it can be a container for other types of messages as needed, and that's basically why this was chosen. Also, we have this concept of resource-oriented approach. This is a RESTful approach where we have very simple and uniform interfaces used to access resources, and a very simple set of commands ultimately that is used to manage the data. It's this create, retrieve, update, and delete set of commands, on top of which we have a notification mechanism, which I mentioned earlier, and which is something that can that is used on top of this REST model. All services that are offered are accessed via addressable resources. We have a URI for each and every resource in the system, which is a way to also disconnect from any addressing system that would come from the transport layer. This is also key in achieving network of being network agnostic, and very important as well is that the project has defined a based ontology for M2M, which can be used as a reference for mapping with maybe other ontologies, and which is also linked to this need ultimately for semantic interoperability, where basically the intent is to give some extra meaning to data, or even I would say meaning at all for data by annotating the data or the resource as it's called here, which is basically a way for the system to be to have better awareness of what the values it is retrieving or updating mean in a specific context, and that ultimately allows for the development of more intelligent applications, I would say, which will know how to handle some specific values based on a better understanding of the context. Next slide is about a set of common service functions which are provided by the common service entities. We will come back to the common service entities. But basically, it was identified in the project that in all these IoT applications, or regardless of the sector, regardless of basically the targeted application, we always come down to a specific and restricted set of features or functions that are needed, and which were so common, I would say, to all the kinds of applications that it was decided, okay, these functions need to be standardized, because that's how you will get the most of the interworking and interoperability. So these functions cover registration, discovery, security, group management, data management and repository, mechanisms for subscription and notification, device management, of course, application and service management, communication management, this network service exposure for the cases where you actually need to know about the underlying layer, location services, and service charging and accounting. And this is really a core set of functions that the OneM2M project believes is sufficient to provide base interoperability for a really large number of applications. Next one, I mentioned that before, a very important principle is abstraction of the transport layer. So the idea is to be transport layer agnostic. Currently, the OneM2M protocols are designed to be transported using IP-based protocols, but it's not the restriction that is built in the project or part of the core principles. It's the way it is for now. We have binding of the service layer protocols to a number of protocols. These are the constrained application protocol, COAP, this message queue telemetry transport protocol, which is I mean, for which we have a dedicated specification, and of course, binding to HTTP. And this was delivered in the first release of OneM2M, and release 2 adds a specification for the binding with the WebSocket protocol, and we have further bindings, I would say, being defined. In particular, here the binding with this data distribution service, which is more of an industrial protocol. And then I would like to move also, because it's a very important topic in considerations about security. And first, I'd like to start with a small comparison. Today, I mean, what we know as consumers is the internet age, where a lot of the data which is captured or acquired is about our environment, and it is used to help us adapt our behavior or to serve us with content which is adapted to us. So there is some kind of indirect privacy threat, and in most of the cases, the security of the services do not directly affect our safety. But for IoT, it's a bit of a different story. The data which is acquired is rather about our behavior, and it's used to adapt our environment. And we have a much higher risk of our privacy being impacted, and also a number of security breaches have a direct impact on our safety. That's why there is a strong focus on security in OneM2M, where security is not seen as something that comes on top of the rest and only after the rest, but rather it's an integral part of the work, and is by design, I would say, a part of the protocols and architecture data structures that are defined in OneM2M. It's very important to us, as we have seen plenty of examples where the IoT, where there are strong cost constraints, sometimes need for a really fast time to market, and also the involvement of a number of players which are new to the ICT to some extent. I mean, this has created some cases where security only comes as a patch on top of the existing application, and we see that this is unfortunately sometimes very easily breached, and it can lead to some rather negative consequences. So here I'd like to mention that it's obviously key to protect critical infrastructure. You have, for example, connected healthcare environments and the related wearable devices, where obviously tampering with the data can have dramatic consequences. We've heard about, I think it was quite recently, we've heard about pacemakers being hacked, which is somehow a kind of concern. And then, of course, intelligent transport is another sector where security is key, where you're addressing part of the road infrastructure, you're addressing the cars, and you're not driving alone on those roads. And of course, for example, when you have vehicle to infrastructure communication, it has to be reliable information. It has to be information that can be trusted. Otherwise, it's basically not going to fly. Smart utilities also, such as meters, utilities that are used for power production, for power distribution, for water distribution, for food distribution and processing, for waste processing, are also things that are the target of attacks and which need to be protected. So, in a very simple way, I mean, critical infrastructure cannot afford a weak security. And what we are talking about, which is more the ICT aspect of it, comes on top of the fact that some of the critical infrastructure are also physically accessible to potential attackers, which means that it's another opportunity for them, another threat for us. OneM2M, in its set of specification, delivers mechanisms that are used for authentication, for authorization through access control mechanism, and secure communications between devices. With the release 2 of the specifications, the authorization system has added a way to grant access in a dynamic manner, which is important if you want to achieve, let's say, a one-time access for resources which is usually not part of the network or not known to the network in advance. It can be negotiated. And also end-to-end secure communication is now something which is supported and which allows for limiting the risk of having let's say, an intermediate node which is compromised and which would either be leaking the data to people or entities that are not authorized, or even worse, actually tampering with the data and affecting the way the service works. Let's now move to architecture. I mean, that one is you will see a number of slides that are presenting about the same thing, each time bringing a different aspect in the picture. Here we have a conceptual architecture view where basically on the left you have the things in the Internet of Things with sensors, devices, or micro-electromechanical systems. And these things are either are in the field domain, and they are either seen as an application dedicated node, which is the simplest of things we can find in the OneM2M architecture, and this is called an application entity. And then they can also be a part of an application service node, which contains, as you see, something called the CSE, which is the Common Services Entity, and which is really the heart of the OneM2M architecture. And the CSE we mentioned earlier in the presentation is the element in the system that supports the common service functions, and this is the one which will provide a consistent set of functions in all parts of the system, and these functions can be accessed through an API which is used by the application entity, and which allows basically or enables the whole communication between the different elements in the OneM2M architecture. And the CSE is very specific in the way it is the as we saw, there is a function for the management of data and the storage of data, and the CSE actually hosts the resource tree, which is basically where the data and all the values exported by or made available by the sensors and the various things in the system are stored. Then you see that there is also this concept of a middle node, which is also sometimes known as a gateway in the network. And from on the right, then we move to what we call the infrastructure domain, which is more on the network side, and where we have the infrastructure node, which is somehow the top of the tree in the service provider network or OneM2M architecture, and that one will be the one which is the reference, I would say, or the and the one which is probably also the one which is exposed to the outer world if there is a need to be visible from the outer world. As you can see to the right, there is also a possibility of having this application entity in the network, and that's because we were talking earlier about data producers and data consumers, I would say. You may have, let's say, if you have a mobile application which is intended to interact with the rest of the OneM2M architecture here, this will also be considered an application entity which will connect to one of the common service entities in the network to address or to be able to access specific resources. And what is important as well is that when the resource you want to access is not the one, when the resource you want to access is not hosted in the common service entity you are connected to, then there is a hop mechanism in the system that will allow the system to propagate your request and make sure it reaches the right resources and is routed back to the requester, so that there is no need to go and browse through all the common service entities in the architecture to try and find, with some kind of trial and error approach, the resources you're looking for. You only need to be connected to one common service entity, and you maintain that connection to that specific common service entity, and the system will make sure that all resources in the system can be accessed through that, and through an established routing mechanism. Next slide is about, it's basically displaying the same architecture in a horizontal manner, where, and it's maybe easier to relate to this application layer, service layer, and network layer I had in the previous slide in the presentation. But what I want to show here is that we have interfaces here, which are called MCA, MCC, MCN, and to the right, if you can see, MCC prime. And these interfaces are basically the key to link the devices and the common service entities. What should be noted is that the MCA is the interface between the application entity and the common service entity, and which allows the M2M applications to access the common services that are hosted by the CSE. So, and by services, I mean both the functions that we discussed earlier and the resources that are hosted in the CSE. And as we saw on the previous picture, there is no restriction on whether an application entity and a common service entity can be hosted in actually the same physical device. Then we have, I would briefly touch on the MCN, which is just the interface between the common service layer and the underlying network, which is actually not that critical from the application standpoint, because the intent is to have an abstraction of the transport layer. But I mean, it's there for when it is actually necessary to get information from the underlying transport layer. Then we have this access through the MCN, and then, of course, as I mentioned, because we have a distributed architecture which is resource-based, we will use this MCC interface to connect one CSE to another CSE, and where this will allow propagation of requests and things like this. To the right, we have this MCC prime interface, which is used to connect the infrastructure CSEs from two service providers, and which basically is used to connect two OneM2M architectures together. And I think the next slide is about the topology. As you can see, it's another way to represent the same thing. It shows clearly that we have the infrastructure domain, let's say, on top, and all which is below is considered the field domain. And you can have application entities which are in dedicated nodes, which connect to the rest of the three through CSE, or even systems where you have a CSE and application entity hosted in the same device, as I mentioned earlier. And all of this feeds ultimately back to the infrastructure CSE, which can also be addressed directly by application entities. That's all I think on my side. I will just mention that at the end of the presentation, which I think will be made available on the website, I have inserted a link here to other webinars that have been provided by OneM2M. There is also a repository of OneM2M presentation on SlideShare, all of which can be found on the OneM2M website. A number of white papers have been published, and I would like, as Sachin mentioned earlier, to stress that there is one on the Smart Cities Done Smarter, which was just issued, and which is really fresh content for you to get. And OneM2M is actually also preparing 8 different developer guides with example and use cases related to security, device management, and all of this. And I will actually, in the presentation which is made available, provide a link here to that content. Also, one last thing I wanted to mention is the work with 3GPP to make sure that there is interworking with 3GPP and their cellular IoT work with LTE-M and NB IoT, and I think also maybe EC GSM. And then I think this was also mentioned by Sachin. Last thing at the bottom is to mention that the technical plenary 31 of OneM2M will be held in India in September. Location is still to be confirmed, as far as I understand. And that's it on my side. Thank you all for your attention. And you have the contact details at the end, with the TSDSI, of course, being the India's OneM2M partner. Thank you.
Thank you very much, Xavier. We are not done yet. We have some questions waiting for you. So if you can see a questions tab, there is some questions already waiting for you.
Yes.
And meanwhile, for the participants, you can locate the questions tab and you can start typing your questions and I will assign them to Xavier.
Okay, okay. First thing, maybe I take that with someone wanted to have look again at slide 1 and 2 of security. Okay. I don't know what if there is a question about this. If this is just a matter of seeing what was written here, this will be distributed later. Sorry. So we'll go for the question, the first one, which is, do you have superior layer examples where you have developed these services in collaboration with different industries? Superior layer examples. So let me think about this. I mean, we have this this topic of the interworking with yes, with AllJoin. I think I have mentioned that briefly with OMA as well, and with OMA, that's for the lightweight M2M work. Also, there is a link to their OMA device management work, and this also with the OIC. I mean, this. I don't know if that answers the question from Christophe. Next one, if that's okay to move to the next one, Sachin.
Yeah.
Yes.
So I would appreciate that if you also read out the name of the people asking questions, because maybe they are hearing you and so they have further specific query.
So that they have the keyword to. So the next question, and I'm really sorry if I pronounce Indian names in a bad way. Next one is from Prabhat Gupta. Can I correlate distributed architecture with the commonly used MQTT protocol for things, as in subscribe, publish communication of MQTT? I would say I would have to refer you to people involved in that work. The only thing I can say at the moment is that, I mean, there is this specification. You will see that number, that specification identifier in the slides. This is TS0010, published by OneM2M, and maybe you can find this this answer to your question in that specification. But we will note this question and follow up about this. Then there is a comment and a question from Christophe Gossard. Security does not mean safety, since you talk about actuation of the machine, unless we don't talk about M2M. Can you clarify what you put under the umbrella of security? So I think at the moment, security in OneM2M is about making sure that the data and the resources, I would say, in the OneM2M architecture are accessed by the right people who are known to the system or discovered in a proper way by the system, people who are authorized to actually interact with the system, and we also provide protection of the information exchanged in the communications between the various entities through securing communications. It can be for integrity, confidentiality, or both. So that's what I would put under the umbrella of security. And then, of course, the thing is if ultimately that security is not the proper one to protect the resources in the system, ultimately it may have an impact on safety if it triggers the system to change settings that are have an impact on people interacting with the system. I am then moving to a question by Rahul Kumar. CSC layer architecture will have to be certainly different from OneM2M, specifically looking at diverse complex use cases specific to India. So this is more of a comment. I understand that there is for sure such an amount of M2M deployments in India that it will generate very complex use cases. I would just like to make the people here aware that there are work items in OneM2M which relate specifically to smart city, to connected cars, and to disaster alert service, as well as industrial internet. And maybe those dig deeper in those complex use cases that Rahul mentioned. A question just arrived from Christophe Gossard. What about mobility and the risk associated with this mobility? I don't really have an answer right now for this. We can come back. I would need to inquire with my colleagues.
So I think that is it when it comes to questions. Xavier, thank you for patiently answering them. And I also appreciate your slide on security, number 1, which was also referred by Mr. Vijay Madan. I found that phrase very interesting about today and tomorrow. That that was quite thought-provoking, I would say. So until unless you have any more concluding words for us, Xavier, I would like to thank you for taking out your busy time and taking time out from your busy schedule and making this presentation. And I think it was an important presentation, especially when we are planning a smart city related workshop here in India on 21st of April at C. Campus in New Delhi, and followed by a hackathon later in Bangalore. And you also shared that there is a technical plenary event being organized in India. So there seems to be a lot of action when it comes to OneM2M.
Yeah, I have no further concluding word. Thanks to you as well.
Okay, so thanks and have a good day, and thank you everyone for participating, and we will come back to you with a next webinar on 7th of April, which I already shared the details with you, which will be on information-centric networking, the future of internet. It will be same time, 2:30 p.m. to 3:30 p.m. Indian time, and will be presented by Mr. Samar Shailendra from TCS Research and Innovation. Thanks again.